Now let's start with the topic free fall. Actually, what is free fall? First, we have to understand. For better understanding, I'll give you the simple example. Suppose from any height you are throwing an object. Okay, from any height you are throwing an object. We all know that object will drop towards the ground only. Isn't it? We all know this, that object will drop towards the ground, and that ball we called it the free fall. त्यही बललाई कुनै पनि चीज हामीले थ्रो गर्छ त्यो भुइँमा गएर ड्रप त्यसलाई नै we called it the free fall. Actually, what is free fall mean? What is free falling body? And the definitions we have: a free falling body is a body when it falls from a particular height only under the actions of gravitational force of attraction provided by earth. And another thing you have to remember, that free fall, in order to free fall that objects, the object freely fall hunulai chai there is only one force, that is the force of gravity, that is due to the force of gravity or gravitations. Okay, that is due to only one force of earth, that is the force of gravity. Clear? And another thing what we have to remember, when the object falls from the height, that means sometimes it came in our mind, no? That also we clear that when object falls from a height, कुनै पनि object height for a fall हुँदा झर्दाखेरि that free falling object can change the velocity. त्यसले velocity change गर्छ भन्दैछ. That means if there is any change in the velocity of free falling object or free falling body, that means for this the answer is yes. That means it can change the velocity. That means when the object falls from the height, जब कुनै पनि object height पर fall हुँदा झर्दा चाहिँ के हुन्छ भन्दा चाहिँ त्यसको velocity पनि जति ground को जति भुइँको छेउ जाँदै भुइँको छेउमा पुग्छ त्यति नै त्यसले velocity पनि के गर्दै जान्छ, increase गर्दै जान्छ. Clear? त्यसले velocity के गर्दै जाँदो रहेछ, increase गर्दै जान्छ. And the change in velocity is called accelerations. We know this thing. जुन चाहिँ त्यो change velocity मा change आउँछ, increase हुँदै जान्छ, जति ground को छेउमा पुग्छ त्यति त्यो velocity increase हुँदै जानुको मतलब, that is we know the definition of acceleration, that is change in velocity. That means the velocity change हुँदा, that is change in velocity is called the acceleration. At that time free falling object ma that accelerations will be created. Acceleration, that means the acceleration के हुँदैछ, produced हुँदै रहेछ. And this acceleration is due to the earth's gravitational force. हामीलाई याद छ नि त्यो acceleration के को कारणले भएको, that is due to the earth's gravitational force or due to the gravity of earth. And therefore this acceleration is called the acceleration due to the gravitational force of the earth. अनि त्यही acceleration लाई हामीले के भन्दो रहेछ, that is called the accelerations due to the gravitational force of the earth or accelerations due to gravity. Clear? त्यसलाई नै हामीले के भन्छ, accelerations due to gravity. And this is the important term to remember in the free fall. And this accelerations due to gravity is denoted with small letter z. As we have studied earlier, capital letter G denotes the gravitations. That means gravitational constant, isn't it? So this small letter z denotes the accelerations due to gravity. And the unit of G is the same as that of accelerations. That means accelerations due to gravity को चाहिँ unit के हुँदैछ same, that is meter per second square. Clear? You have to remember this. Now in order to derive the formula, clear? In order to derive the formula for acceleration due to gravity g को formula हामीले derive गर्नुको लागि we have to go back to the Newton's second law of motions. As we all know that in Newton's second law of motions we have studied that हामीले के पढेको थियो भन्दा चाहिँ the force is the product of mass and accelerations. त्यो पढेको थिएन हैन. Force is directly proportional to the mass as well as with the accelerations भनेर we discussed in our previous classes. So here accelerations हामीले अब यहाँनिर what we have to do, as we know that अब हामीले भर्खर मात्रै के पढ्यो भन्दा चाहिँ that accelerations due to gravity g, that is denoted with g, and accelerations with a. So in this formula f is equal to ma. In place of a we can replace this a with accelerations due to gravity g. हामीले a को जग्गामा we can write down the g, that will be force in terms of accelerations due to gravity, and marked it equations number 1. Clear? And another one we have discussed in our previous class. हामीले के पढ्यो अर्को कुरा भन्दा चाहिँ universal law of gravitations in terms of gravitational constant, isn't it? That means we know force in terms of gravitational constants will be F is equal to Z, capital letter Z, capital letter M into small letter m divided by R square. And here we know this G is gravitational constant, M is the mass of Earth, and small letter m is the mass of object, and R is the distance between Earth and the object. This we know, and we'll have the two equations, and we have to combining these two equations. By combining these two equations we'll get left hand side equal, means right hand side also will get equal. So next we'll get mg, m small letter m into small letter z is always equal to capital letter Z, capital letter M into small letter m divided by R square. So here we have in right hand side mass small letter m, and in the left hand side also we have small letter m. These two will cancel out. So in terms of accelerations due to gravity, we'll get the equations z equals to small letter z is equal to capital letter Z, capital letter M divided by R square, where M we know M is the mass of the Earth and R is the distance between the object and the Earth. Now next what we have to do, we will get, that means we will get the formula in terms of accelerations due to gravity. As we all know, let an object be on or near the surface of the Earth, because we are comparing the object with the Earth. So let's an object be on or near the surface of the Earth. So the distance r in this equation, that means g is equal to capital letter Z, capital letter M by R square will be equal to R. That means your distance, like say, we can represent it with the radius of the Earth. Thus, for object on or near the surface of the Earth will be in equations small letter z is equal to capital letter Z, capital letter M divided by R square. And in this equation, R square will be R, that means small letter R square will be capital letter R square. So our equations will be small letter z is equal to capital letter Z, capital letter M divided by capital letter R square. The earth is not a perfect sphere. As the radius of the earth increased from the poles to the equators, the value of g became greater at the poles than at the equator. For most calculating, we can take g to be more or less constant or on or near the earth. Now next we'll calculate. Now we'll derive the formula in terms of accelerations due to gravity, that we have small letter z is equal to capital letter Z, capital letter M divided by capital letter R square. Now we'll do how to calculate the value of g. Okay, how to calculate the value of g. Now here also we have to take the equation, that is accelerations due to gravity. We know g is equal to capital letter Z, capital letter M divided by capital letter R square. And for this universal, that means we know the value for g, capital letter M and capital letter R. That means capital letter Z is equal to 6.7 into 10 to the power minus 11 Newton meter square per kg square. That is on the mass of the earth. And that means next is mass of the earth. That means gravitational constant को mass याद बया मिला है. Now mass of the earth will be m is equal to 6 into 10 to the power 24 kg. And the radius of the earth r is equal to 6.4 into 10 to the power 6 meter. So we have to put these values on this equations. G, small letter z is equal to capital letter Z, capital letter M divided by R square. Now you have to put the value and substitute. And after substituting, we'll get small letter z is equal to 9.8 meter per second square. Thus the value of accelerations due to gravity of the earth g is equal to 9.8 meter per second square. This will get, that means here we'll get the equations for the acceleration due to gravity and the value of accelerations due to gravity. Now next we'll do the motion of object under the influence of gravitational force of the earth, or how to modify the equations of motions in the case of free falling body. That means these two are same. That means the subtopic 10.2.2. Now we know that there are three motions. We study the three equation of motions. That means in the previous chapter we did the three equation of motion, that is mu is equal to u plus at, equation number 1. Equation 2 we have s is equal to u into t plus 1 by 2 into a into t square. And number 3 equations we have v square minus u square equals to 2 into a into s. And here we all know in terms of motion, this u and mu are the initial and the final velocity, and s is the distance covered in time taken. We know this in terms of the motion. Now these equations we have to write down in terms of free falling bodies. Okay, and for the free falling bodies we can write down the accelerations with the accelerations due to gravity, and this s is the distance. We know s is the distance, but this s will be represented with height, because here the distance is the height of the free fall objects. So here we can represent a is equal to z and s is equal to h. So we have to put this value on this in the three equations of motion. So we'll get u is equal to mu is equal to u plus at equals to, in place of u we have to u that means we have to keep this v as it is equals to u also as it is, plus in terms of a we have to put g. So we'll get the first equation in terms of free falling object is v equals to u plus z into t, and number 2 equations will be, in terms of s we have to put h equals to u into t plus 1 by 2 into, in place of a we have to put g, so g into t square. This will be our second equation. And the third equation, v square minus u square is equal to 2a into s, and v square minus u square is equal to 2. In place of a we'll put g, and in place of s we'll put h. And this is the equation in terms of free falling bodies.